Okay, to figure out the inverse function for the aim function, we have to look at the steps of the aim function. First one is double, second one is add, and we need to undo those in backwards order. So I'll start out undoing the add 1 by doing the opposite, which is subtract 1. Then after that, I will do the opposite of doubling something, which is halving it or dividing by 2. Then I'll do an example of the aim function. I'm just going to use the same pair of numbers, the 10 and 21 that was in the example for the aim function. I'm going to do the inverse aim function of 21, and then I'll subtract 1 from that, which will give me 20. I'll divide by 2, which will give me 10, equals 10, exact opposite of the aim function. Alright, now for the inverse JOP function. The last step in this one is to multiply by 6. So, to undo that, I will divide by 6. And then the other step is to add 3, so I'll undo that by subtracting 3. Okay, next, an example. So inverse JOP function. I'll put a 66 in, using the same numbers as before, but just the opposite order. So 66 divided by 6 is 11, minus 3 is 8. Alright, now for the inverse kicks function. So, the rule is that any even number goes to 0 and any odd number goes to 1. But I can't really think of a way to go backwards. Like, because what number does 0 go to? Any even number could have made a 0. You could have had a 22 making a 0, or a 24 making a 0, or tons of any even number makes a 0, and any odd number makes a 1. So I don't know how to go backwards. Like, what a 1, I don't know what odd number that was. So this is actually impossible. There's no inverse function for the kicks function. Alright, the inverse BP function. Alright, our last step for the BP function was to add 3, so I'll undo that by subtracting 3. Next step, multiply by 2. I'll undo that by dividing by 2. And then the very first step of the BP function, I'll undo that by doing the opposite of subtract 1, which is plus 1. For my example for the inverse BP function, I'll use the same numbers, 43 and 21, so inverse BP. So I'll put 43 into the function, and I'll subtract 3 from that to get 40. I'll divide by 2 to get 20. I'll add 1 to get 21. And then they're the same two numbers for the BP function, but in the opposite order. Alright, the inverse SVDI function. The SVDI function only has one operation, divide by 7.3. And even though 7.3 is a decimal, you still undo it the exact same way. It's just going to be one step, and the opposite of division is multiplication. So we're going to multiply by 7.1. Whoops, sorry, 7.3. Our example of that, so for the inverse SVDI function, whoops, sorry about that. Well, I will put the number 2 in, and if I do 2 times 17.3, it equals 14.6. Okay, next trying to figure out the inverse h function. And I see that the h function counts how many digits are in a number. For example, the number 17 has 2 digits. Some other numbers that have 2 digits would be 99 or 56 or 47. All of those are going to output a 2 from the h function. And there's a lot of numbers that go to 1, like if you put a 1 into the h function, you get 1, or a 7, you get 1, because that's just a single digit number. And because there are lots of numbers that output to the same number, it's not possible for me to know if, for example, for the inverse, if I were to do inverse h function of 3, how am I supposed to know what 3-digit number it was that the person put in to get a 3? There's no way for me to go backwards since there's so many possibilities of 3-digit numbers. It's just not possible to make this inverse function. So there's no inverse function for the h function. Alright, so we need to figure out the inverse of the square root function. The square root function, or the sqrt function, only has one thing that it does. It takes the square root, and the way to undo a square root is to square something. And remember, square means to multiply a number by itself. So if I do the inverse sqrt function, I'm going to use the number 7. So all I have to do to the number 7 is square it. That means 7 times 7, and I get 49. Alright, for the inverse Pilio function, the step that I need to undo first is the subtract 3. Remember, we undo the last step first. So undo subtract 3 by adding 3. Next step, undo squaring something by taking the square root. And then the very last step, undo add 2 by subtracting 2. Now I'm going to do the inverse Pilio function to the number 78. I'll start out by adding 3, which gets me 81, and then I'll take the square root of 81, which is 9, and then I'll subtract 2, which equals 7. Alright, now trying to find out the inverse y function. The y function has 4 steps, so the inverse y function is also going to have 4 steps. So first I'll undo the divide by 2 by doing multiply by 2. Next I'll undo subtract 10 by doing plus 10. Third step, I will undo multiply by 4 by doing divide by 4. And then the fourth step, I will undo add 7 by doing subtract 7. And let's see, the inverse y function, if I put the number 11 in there, let's see what happens. 11 times 2 is 22. Then you add 10, you get 32. You divide by 4, that gives you 8. And then you subtract 7, that gives 1. Which makes me think I did something wrong, because it should be 15. Let me try it again. So maybe, let's see here. Maybe this example over here is wrong. Let me try this out. Let's see. If I do 15 plus 7, that gives me 22. And then I do 22 times 4, I get 88. Then I do 88 minus 10, I get 78. Then I divide by 2, 78 divided by 2, and that gives me 39. So this is wrong. It should be a 39 right there. Okay, so I found a mistake in the assignment. So instead of putting an 11 in, I'm going to erase that 11 right there, and I'm going to put a 39 in. So let's put 39 in. 39 times 2 is 78. Then plus 10 is going to be 88. Then divided by 4 is 22. And minus 7 is 15. So that looks better. So we always want to remember that the inverse function has the input and the output switched. Alright, so for the inverse Scheider function, it has 4 steps, so we'll undo those one at a time. To undo, divide by 2. The opposite of that is times 2. To undo, add 4, you subtract 4. To undo dividing by 3, you multiply by 3. And to undo doubling something, you half it, which is the same as dividing by 2. So let's see if this works. Inverse Scheider function. I'm going to put the number 7 in and see if the number 15 comes out. So 7 times 2 is 14, minus 4 is 10, times 3 is 30, divided by 2 is 15. So that works. Alright, so the inverse XUP function. The XUP function has 5 steps, so the inverse function is going to have 5 steps also. So let's undo them one at a time. To undo, add 3, you subtract 3. To undo, divide by 2, you multiply by 2. To undo, subtract 4, you add 4. To undo doubling, you divide by 2. To undo adding 3, you subtract 3. Alright, let's check this out. So inverse XUP function, I'm going to plug in 11, see if I get a 7 out. So 11 minus 3 is 8, times 2 is 16, plus 4 is 20, divided by 2 is 10, minus 3 is 7. So, yep, that looks like it works. Alright, last one is the love function. We're trying to find the inverse love function. So it's going to have 7 steps. So to start out with, first step, to undo doubling, you divide by 2. To undo subtract by 1, you add 1. To undo multiply by 4, you divide by 4. To undo add 11, you subtract 11. To undo divide by 3, you multiply by 3. To undo subtract 7, you add 7. And to undo multiply by 10, you divide by 10. So let's check this out. We'll do the inverse love function for the number 94 and see if we get 1 out of that. So 94 divided by 2 is 47. Plus 1 is 48. Divided by 4 is 12. Minus 11 is 1. Times 3 equals 3. Plus 7 equals 10. Divided by 10 equals 1. So that looks like it works.